today's class we are going to solve this numerical. The numerical we have in this numerical we have to find the settlement. What will be the settlement of the foundation for this given problem? Okay, so here we are given there is a square footing, okay, of 2 meter size, which rests on a soft clay soil, and its base is at a depth of 1.5 meter from ground surface. The clay stratum is 3.5 meter thick and is underlain by a firm sand stratum. So from this line you should understand that if this is the ground level, then the particular foundation, whatever the particular footing is here, okay, this footing, the base of the footing is at a depth of 1.5 meter from top. It's at a depth of 1.5 meters from top, and this is a clay soil. It is written here is a clay soil, okay, and it is of 3.5 meter thickness. The whole clay soil is 3.5 meter thickness, means from here, that is from ground level, the whole thickness of the clay soil is 3.5 meters. Below it there is a firm sand stratum. Here it is sand stratum, okay, firm sand stratum. So in problem it is given this way, okay. So the clay soil has liquid limit of 30%. Now where the liquid limit comes in picture, okay, so what they asked to calculate the settlement, okay. Settlement means what? We have to find delta H. Delta H is given as equal to delta H by H is nothing but equal to compression index Cc by 1 plus initial void ratio into log of 10 sigma 0 plus delta sigma by sigma 0, okay. So exactly we have to find here what is the void ratio, what is, okay, this is the H0 in this case, this is the H0 in this case, and it can be calculated as 3.5 minus 1.5, that is 2 meters, okay. So H0 in this case is, this is H0, okay. So this is given as 2 meters, okay. So now in this case we have to find what is compression index, what is the initial void ratio, what is sigma 0, that is soil, that is initial effective overburden pressure, okay. So that is the initial effective overburden pressure, and what is the delta sigma. Delta sigma is nothing but increase in pressure intensity, at this level xx, and this level xx, okay. This level xx is nothing but center of this h0, center of h0, means what is the half the distance of h0. What is h0? 2 meters. So this axis distance will be equal to 1 meter, okay. Whenever we find what is the change in stress, okay, whenever we have to find change in stress or sigma 0, we have to find delta sigma and sigma 0 for a given foundation. The whatever the soil strata depth is there below the foundation, if this is the soil strata depth of the below the foundation, that is the H0. So at center we have to find its delta sigma. Okay. Delta sigma is due to the increase of pressure intensity. Delta sigma, that is the change in stress due to the presence of this footing, or this footing is causing. Okay, and then we have to find sigma 0, that is the initial overburden pressure. Initial overburden pressure at this line. Okay, means at h0 by 2. At h0 by 2. Always remember this thing. Always remember this particular thing. Okay. So for finding CC, that is compression index, so as we studied earlier, compression index can be found out by initial pore water pressure minus pore water pressure excess by initial pore water pressure. This way you can find into 100, or not compression index, this is U. Okay, that is degree of consolidation, and degree of consolidation also can be found out by delta H at any given time by total settlement, delta H, capital delta H. But since there is no time factor given, there is no time given, there is no U given, there is nothing given. Okay, so in this case, how we can find CC, that is compression index. Okay, so to find compression index we can use, but in the problem there is one thing given, that is the liquid limit. The problem has given us the liquid limit value, that is 30%, and whenever the liquid limit value is given, you can directly find the compression index CC using liquid limit as 0.009 liquid limit minus 10. Okay, compression index, compression index, always remember CC can be found out as 0.009 liquid limit minus 10. Sometimes liquid limit is also written as WL also, liquid limit. Okay, so always remember this thing. So we can find compression index directly. CC is nothing but 0.009. How much liquid limit is given in the problem is given 30%, that is 30 minus 10, that is 30 minus 10, that is comes out to be 20, and it comes out to be 0.18. Okay, so compression index comes out to be 0.18. So now we found out that one thing. Okay, so we have found only one thing. Now we have to find this initial overburden pressure, change in stress due to presence of footing. Okay, then we have to find the initial void ratio. All these things we have to calculate. Okay, this 1, 2, 3 things we have to find out. So how we will find out all these things? Okay, so in problem, what is given, that if you look at the problem, we need to find all these things. So if you look at the problem, it has given something as like specific gravity, and then it has given everything, compute settlement, content of saturation, water content at saturation is 40% is given. Okay, so all these things are given. The factor of safety, bearing capacity factor. Now this is the thing, it has given the bearing capacity factor NC. Okay, so where does the NC comes? NC is the Terzaghi factors, NC, NQ, and N gamma. Terzaghi factor for cohesion, and so on. So these are the factors that are here. So and problem is given is what? It is of square footing. It is square footing. So for square footing, what is the Tarzagi equation? So before going for the Tarzagi equation, first we should find out whether the depth, whether the footing is given is a shallow foundation or a deep foundation. For shallow foundation, the depth of foundation by breadth of foundation should be less than 1, or you can say that depth of foundation should be less than breadth of foundation. If this is our foundation is given, okay, and this is the ground level, then this is the depth of foundation and this is the breadth of foundation. So in the problem, whether the depth of foundation given, yes, it is 1.5 meter, and this is the breadth of foundation is given, yes, it is of 2 meters size. So depth and breadth of foundation are given. So depth of foundation is given as 1.5, which is less than breadth of foundation, that is 2.0. Hence we can say that it is a shallow foundation. And for shallow foundation we can write, and for shallow foundation having square footing, we can write Tarzaki's equation as for bearing capacity Q, ultimate bearing capacity of soil QU is given as equal to 1.3 CNC, 1.3 CNC plus gamma D F NQ plus gamma B N gamma. Okay, from these factors in problem the NC values is given only. NC value is given as 6.9 in the problem. As we can see, the NC value is given as 6.9 capacity factor. Okay, that is given as bearing capacity factor. Then what about the NQ factor and N gamma? How to find these things? So in the problem it is given that is a clay soil. This one hint is given. This is a very interesting one because many things you have to find out by yourself. Soft clay soil. Since the clay soil is given, for clay soil only cohesion is present, okay, and shear resistance, internal shear resistance factor, internal angle of internal shear resistance phi is 0. Okay, cohesion is given. How much is given? Is given as 0.5 kg per centimeter square. So for clay soil cohesion is given, whereas for clay soil phi, angle of internal shear resistance, phi is given as 0. Phi is also 0. So for this case, like if you know, so you should know always that phi is equal to 0, NC is 5.7. If in the problem NC is not given, you should assume for pure clay soil NC as 5.7, NQ as 1 and N gamma as 0. Okay. So for phi is equal to 0 degree and C is equal to 5.7, but in our problem it is given as 6.9, so we don't have to assume this particular value. NC is 5.7, NQ is equal to 1 and n gamma is equal to 0. Nc is equal to 5.7, nq1 n gamma is equal to 0. So we will write nc is equal to 6.9, nq1 n gamma is equal to 0. So ultimate bearing capacity of the soil Qu is given as equal to 1.3 CNC, NQ is 1, so it comes out of gamma dF, n gamma is 0, so everything gets to 0. Now here this gamma is gamma dash, because again you have to read the problem very carefully for that thing. N gamma, because in this problem, in this written settlement natural water table is quite close to the ground surface. It is written natural water table means water is at near the ground level, so you can say that water is here, somewhere here, as close as possible to the ground level, water level. So hence here the density of soil will be given gamma dash, that is gamma submerged. The soil will be submerged. Soil will be considered as a submerged soil. Now what we need to find exactly? Q safe. We need to find Q safe. Why we need to find Q safe, you may ask? Because in the problem it is given the like compute the settlement that would result if the load intensity equal to the safe bearing capacity. Okay, so you want to find the safe so this is ultimate bearing capacity, and we have to find the safe bearing capacity. So from ultimate bearing capacity, how we find the safe bearing capacity? From ultimate bearing capacity, you have to find net ultimate bearing capacity. Q net ultimate bearing capacity can be written as 1.3 CNC plus gamma dash dF, that is nothing but Qu minus gamma dash dF minus gamma dash dF. It comes out to be 1.3 CNC. Because it is net, we should not consider the overburden pressure of the soil. We consider that when you dig the trench for the foundation, dig the hole for the foundation, you have removed the soil. Since you have removed the soil, you have also removed the weight of the soil, that is gamma dash या फिर pressure due to soil, that is gamma dash dF. In this case gamma, that is gamma of soil into depth of foundation, it is considered this way. Okay, so when you have removed, so it is considered. So when you are putting a foundation above a hard strata, when you are removing the soil, so you have removed the self weight of the soil also, or the pressure created due to the presence of soil also. Hence net ultimate, that is Q net ultimate of the soil, can be considered as Qu minus gamma dash dF. Then from Q net ultimate we have to find Q net safe. Okay, Q net safe. Q net safe is nothing but Q net ultimate divided by factor of safety. Q net ultimate divided by factor of safety. So in the problem, does the factor of safety is given? Does the factor of safety? Yes, factor of safety 3 is given. Factor of safety 3 is given. So we can write this thing as that is 1.3 CNC by 3. And write this thing. Well, now this is net safe. So what will be the Q safe from this? From net ultimate we have found the Q net safe, and from Q net safe we will find the Q safe. So just remember this thing. First we find the ultimate bearing safe capacity QU. Okay, from QU we find the Q net ultimate by subtracting the pressure due to soil, which is created pressure due to soil, by removing the pressure due to soil, that is gamma dash or gamma of soil divided into df. Then we have to divide by factor of safety. Then we have to add again. Now we have to add again that particular soil pressure due to soil which was removed earlier, that is 1.3 CNC by 3 plus gamma dash df. This is how we find the Q safe. This is how we find the Q safe. Okay, this is the whole process of finding Q safe. So we have to find first Q safe, because in problem it is said that due to the what in the presence of the safe bearing capacity, what will be the final settlement. This Q safe is causing this final settlement. So what this final settlement will be? So first you have to find what is the Q safe, and for that you need CNC. So it is given CNC, we know that in the problem. So we also know depth of foundation, we also know that is 1.5. So but C is given as position is given as 0.5 kg per centimeter square. So we just have to convert it into kilonewton per meter square. Okay. Whereas gamma dash and depth of foundation is given as 1.5 meters, so it's not an issue. And C is given as 6.9, so it's not an issue. So what rest we have to find is gamma dash, that is submerged. Gamma dash, that is gamma submerged. Gamma submerged is nothing but gamma sat minus gamma w. Okay, so gamma, that is bulk density, is given as G plus E into degree of saturation ESR by 1 plus E into gamma W. Okay, now for saturated soil SR is equal to 1, so gamma sat becomes is equal to G plus E by 1 plus E into gamma W. Okay, so from this I will minus gamma W, so gamma submerged will be equal to G plus E by 1 plus E gamma W minus gamma W. So it comes out to be G minus 1 by 1 plus E gamma W, that is the submerged unit. So that's the submerged unit. So for gamma submerged, do we know G specific gravity? Do we know void ratio? Do we know specific gravity in the problem? Yes, we know the specific gravity in the problem. Where is that? Specific gravity, that is given as 2.7. Okay, so G is given 2.7. Where is the void ratio? Void ratio is not given in the whole problem there is no water ratio, but there is one thing given: water content at saturation. Okay, water content at saturation. So can you use that thing to find E? Now we know a general term, that is Wg is equal to ESR, correct? Now in this case, water content is given as what? How much water content is given? 40% is given. And at what is this 40%? At saturation level, means at SR equal to 1. So, and we know the G, so we can find out E, that is 0.4 into degree of saturation, that is 2.7. That's the way we find the E, that is void ratio. So G, that is the specific gravity, is given as 2.7 minus 1 by 1 plus 0.4 into 2.7 whole multiplied by gamma W, that is 9.81, that is gamma submerged. So while after calculating this thing, we get the value as 8 gamma submerged at 8.02 kilonewton per meter cube. Gamma submerged comes out to be 8.02 kilonewton per meter cube. Okay, so we found the gamma submerged. Now what we need to find again? So this is a very long problem. This requires a lot of calculations, so you have to do one by one. Since problem is still not over, we are still in the middle of the problem. Okay, so we will look further what we need to find more. So we have found what is the gamma submerged, we have found the void ratio E. Okay, so and using this we have to find what is now Q safe. So as earlier we have found, Q safe is nothing but Q net safe plus what is the pressure of soil which is removed during excavation, that is gamma dash df, that is Q safe. So again we have to know, first we have to find the QU for a square footing is nothing but 1.3 CNC plus gamma D NQ plus gamma B N gamma. Okay, since it is pure clay, it is pure clay soil which is also submerged, hence gamma becomes gamma submerged, that is equal to gamma dash, whereas cohesive value is given, but for pure clay angle of internal friction phi is always equal to 0. For this condition we should always know that NC is 5.7, NQ is equal to 1 and gamma is equal to 0, but in this case 5.7 we will not use, since in the problem it is given as 6.9. okay, but you have to remember, if it's not given you have to consider as 5.7, NQ as 1 and N gamma is 0. So from this our QU term becomes 1.3 CNC plus gamma dash depth of foundation. This D is nothing but here is depth of footing. What is the depth of footing? Now from this we find out QU net, Net ultimate is nothing but 1.3 CNC plus gamma dash df minus gamma dash df. That's the Q net ultimate. Qu net is nothing but 1.3 CNC. Okay, 1.3 CNC is nothing but net ultimate. Okay, so after finding Q net ultimate, then we have to find Q net safe is nothing but Qu net divided by factor of safety. In the problem, the factor of safety is given as 3, and it will be equal to 1.3 CNC by 3, and from this Q net safe we have to find Q safe, and Q safe is nothing but 1.3 CNC by factor of safety, that is 3, plus again, now what we have minus earlier, we have to add that again, that is gamma dash df. So from this we can find Q safe as 1.3 divided by 3 into, this is given as C, cohesion. Now in this case, the cohesion, this problem, the cohesion, the C value, the cohesion value, how much it is given as 0.5 kg per centimeter square. We have to convert it into kilonewton per meter cube. Okay, so we have to convert it into kilonewton per meter cube. So C is given as 0.5 kg per centimeter square. 0.5 into 9.1, 9.81, that will be what? Kg will convert into Newton. Newton will get converted by multiplied by minus 10 raised to minus 3, 20, that is kilonewton. Okay, per centimeter squared is again per meter cube. Okay, 1 meter is equal to 100 centimeter, and it is what? 1 centimeter is equal to 10 raised to minus 2 meter. Therefore 1 centimeter square is equal to 10 raised to minus 4 meter square. So it comes out to be 10 raised to minus 4 meter square. So this is the C term, and C is given as 6.9 plus gamma dash. How much gamma dash we have calculated? How much gamma dash submerged? Just gamma submerged is 8.02. Gamma submerged is 8.02. So this whole terms becomes, I will write here again, that is 1.3 into 0.5, that is the C term. It is all C term, that is into 9. We have converted C from kg per centimeter square to kilonewton per meter cube into 10 raised to power minus 3 divided by 10 raised to power minus 4. So this becomes in kilonewton per meter square, sorry, kilonewton per meter square. Okay, then multiply by NC, that is 6.9 divided by factor of safety 3, gamma dash, gamma submerged is given as 8.02. the depth of foundation is given as 1.5. okay, that is the depth of foundation. This is the footing, this is the ground level, and this is your depth of foundation. So from this the Q safe comes out to be, from this we find by calculating this thing, Q safe comes out to be, how much Q safe comes out if you calculate this thing, comes out to be 158.68 kilonewton per meter square. That's our Q safe. Now this Q safe acts at the base of this footing. Okay, it's acting here at the base of the footing. Base of the footing is what? Of 2 meters, and the whole soil, clay soil, this is your ground level, This is, so from the clay soil, from the ground level, how much it is at depth? It is at depth of total, this much is given as 3.5 meters. This is given as depth of foundation is given as 1.5 meters. So remaining this much distance is how much? 3.5 meters, that is 2 meters. Okay, now we have to find, now from using this thing we have to find sigma 0 overburden pressure, sigma 0, that is initial effective overburden pressure, sigma 0. But where do we find the sigma 0? At the middle of this soil, which is below the footing, and at the end where the soil is present, below that this is sand. Okay, so at the middle part will be at what? At 1 meter from the base of the foundation. We have to find the pressure increases this way. The pressure increases at the rate of 2 by 1. Okay, 2 by 1. Okay, so we have to find initial effective overburden pressure, that is sigma 0 bar, and then we have to find increase in pressure intensity, and let's consider this as level xx. Okay, then we have to find delta sigma bar, that is the increase in pressure intensity, increase in pressure intensity, pressure intensity. We have to find this thing. So how we will find out these things? How do we find out these things? So that's another thing we have to find. Okay, so first we know that this Q safe is acting at here. So at here the area is what? 2 by 2 square footing, that's 2 meter by 2 meter. Therefore PU, that is P safe, you can say that P safe, load safe, is given as 1.1, sorry, is given P safe can be given as, let's erase this first. P safe, so P safe can be found out, that is in kilonewton, is 158.68 into 2 meter into 2 meter, that is area of footing. Okay, so if here we found the P, then we have to find Q safe at xx, so that will be equal to what? P safe divided by area at xx. What is the area at xx? So P safe is nothing but 158.68, this 2 into 2 is nothing but 4. Area at xx, what is the area of xx? So we know the particular this pressure intensity increases at the ratio of at 2 vertical to 1 horizontal. If this is 2, this will be 1, but in this case this much is distance is what? 1 meter. So for 1 it will increase 0.5 here, and it will increase 0.5 here, and in between it is already 2 meters, so it becomes 3 by 3. The Q safe at xx is nothing but 70.52 kilonewton per meter square. It comes out to be 52 kilonewton per meter square. Okay. So that is nothing but this Q safe at this thing is nothing but equal to delta sigma bar. Yeah, because this is due to the increase in pressure intensity due to presence of the particular given footing. Okay, now initial effective overburden pressure. Now initial effective overburden pressure at xx, that is sigma 0 bar. You have to find that is initial effective overburden pressure at xx is given as sigma 0 bar, and to find the sigma 0 bar, what will be sigma 0 bar means what is the xx distance from top, from ground level. This is ground level. Okay, so from here how much distance it is? So footing is at a distance of 1.5 and xx distance from base of the footing is 1, so it comes out to be 1.5 plus 1, that is 2.5 meters. Okay, so 2.5 is the distance, multiply by what? Multiply by gamma dash, that is the saturated unit weight of the soil, gamma dash, sorry, submerged unit weight of soil. 2.5 into gamma dash is given as 8.02, so it comes out to be 20.05 kilonewton per meter square. So this is sigma 0 bar. And earlier we found cc also, that is compression index. Now the problem has literally come to an end. Compression index we have earlier found out at the starting only. Compression index comes out to be 0.18, that is 0.09, liquid limit minus 10. By doing that we get compression index. So at last we can find delta H, that is total settlement by H0 is nothing but Cc by 1 plus E0 into log of 10 of initial overburden pressure, the increase in pressure by initial overburden pressure. So we can find delta H equal to, now what is H0? H0 is like what is the distance of foundation. If this is the your ground level, this is 1 point, so this and this is given as 3.5, so this much is what? 2.0 meters. So this was H0 we have already calculated. So this is 2 into compression index is 0.18, initial void ratio plus void ratio, what we have find out as 2.7 into 0.4, that is G into water content, then log of 10 sigma 0 bar, that is 20.05 plus 70.52 by 20.05. So delta H comes out to be 0.11335 meters, and that's our answer. So thank you for watching. See you in the next class.